Let's look at one more example that involves perhaps multiple equations of tangent lines. So I want to find y prime, the derivative, and the equations of the tangent lines to the graph of y equals negative xy squared plus x squared plus 1 is equal to 0 at the points where x equals 1. So I'm going to start with my equation y minus xy squared plus x squared plus 1 is equal to 0, and I want to take the derivative of each side with respect to x. Oops. So okay, derivative of y with respect to x, we know that's going to be 1 times y prime. Derivative of xy squared. Here we need to be careful for two different reasons. First of all, xy squared, I actually have a function of x, which is just x, times a function of x, which is y squared. I actually have a product rule happening here. We said earlier, if you ever have a function, a power of x times a power of y, that's going to be a product rule. So again, be very careful with this guy right here. We have to use our product rule. So perhaps off to the side, let's just do that over here. I'm going to call this guy f, and I'm going to call this guy g. F is equal to x, which means that f prime is equal to 1. G is y squared, so g prime, derivative of y squared, that's going to be 2y. But again, I'm using the chain rule because y is a function of x, so I need to multiply that by y prime. So 2y, y prime. So let's see, minus f prime times g, I'm going to have 1 times y squared, plus for my product rule, I'm going to have f times g prime. I'll have x times 2y, y prime. Now I said this is kind of tricky for two reasons. The first was that we were using the product rule. The second is actually because of this minus sign right here. Because what I need to do is I need to subtract this whole product rule. So the way I'm going to do that, I'm just going to put this part in parentheses so that I know in the next step, hey, I need to take this minus sign and perhaps distribute it to each term inside of my parentheses. So be careful when you have that minus sign in front of the product rule. It's a really easy thing to overlook. All right, derivative of x squared, that's going to be plus 2x. Derivative of 1, that's a constant, so that'll be plus 0 is equal to derivative of 0 on the other side is also just 0. So let's just clean this up a little bit here. I've got y prime. I'm going to take this minus sign here. Let's take this minus sign and distribute that. So let's see, I'll have minus y squared minus, I'm just going to reorder some of the terms right here, or some of the factors, excuse me. I'll have minus 2xy, y prime, plus 2x is equal to 0. So it looks like there's a lot happening here. But remember what we're trying to do. We're trying to solve for y prime. So what I'm going to do is I'm going to leave the two y prime terms on the left-hand side of my equation. I'm going to take the two terms that do not have a y prime. I'm going to move those over to the right-hand side of the equation. So I should have y prime minus 2xy, y prime is equal to y squared minus 2x. Now my left-hand side, both of those terms have factors of y prime. We can factor that out. Y prime, that's going to leave me with 1 minus 2xy is equal to y squared minus 2x. And then I'll just divide by that 1 minus 2xy. So y prime equals y squared minus 2x divided by 1 minus 2xy. Here is my y prime. So there's the first part. I found the derivative. What else did we want to do here? So let's erase. I want to find y prime. Well, I did that. And the equations of the tangent lines to the graph at the points where x is equal to 1. So here's y. Let me just write down my equation down here so I don't have to keep going up. Y minus xy squared plus x squared plus 1 is equal to 0. And we said we were working with x equals 1. So again, I'm perhaps a little bit cautious here because I know that we're working with something which is not a function. I may end up with multiple y values. So my suggestion is always to go find your y value first. So I'm going to work with that original function. I'm going to take x equals 1. I'm going to plug that into my original equation. I'm going to solve for y. So let me do that. Let's do that in red. So y minus x, that's 1 times y squared, plus x squared is also 1 squared, plus 1 is equal to 0. I've got y minus y squared plus 1 equals 0. So I have negative y squared plus y plus 2 is equal to 0. I have a quadratic equation here in terms of y. I never like my quadratic term to be positive, so I'm going to multiply both sides by negative 1. That'll leave me with y squared minus y minus 2 is equal to 0. If I look at that right-hand side, or excuse me, the left-hand side, I can factor that. So I will have y minus 2 times y plus 1 is equal to 0. Gives me y equals 2. And y equals negative 1. So I do have multiple points, which means I'm going to have multiple tangent lines. This means that I have a point at 1, 2, and I have a point at 1, negative 1. Because my x value is always 1, it's just my y value that's changing. So let me see, what do I want to do? I think I want to scroll down just to give myself some more room. We said we have the point 1, 2, and we have the point 1, negative 1. I have the points, which means the only thing I'm missing is the slope of the two tangent lines. And for the slope of the two tangent lines, I'm going to look at my derivative. I'm going to look at y prime. So let's write that here just so that I have it. Y prime is equal to y squared minus 2x divided by 1 minus 2xy. So here is my derivative. I'm going to take my x value, plug it in for x, the y value, plug that in for y, solve for y prime. That's what tells me the slope of the tangent line. So y prime equals, let's see, I'll have 2 squared minus 2 times 2. 2 times 1, my x value is 1. Divided by 1 minus 2 times x is 1, times y is 2. So I've got 4 minus 2 divided by 1 minus 4. Let's see, I should have 2 over negative 3, or negative 2/3. Remember that this is the slope of your tangent line. So if I wanted to write the equation of the tangent line at 1, 2 with a slope of negative 2/3, I would have y minus 2 equals negative 2/3 times x minus my x coordinate is 1. And again, you would take that and just solve it for y. I'll leave that for you to do. Over here at 1, negative 1, since we have a different point, we are probably going to have a different slope. So I'm going to plug this point again into my derivative, into y prime. So y prime equals, let's see, y squared, that's negative 1 squared, minus 2 times 1, divided by 1 minus 2 times x. That's 1. Y is negative 1. So I have 1 minus 2 divided by 1 plus 2, looks like. Yeah. So 1 minus 2, that's going to be negative 1. 1 plus 2, that's 3. Negative 1/3, that is my slope. So I've got my point, I've got my slope, I've got everything I need. I can write the equation of my tangent line. I'll have y minus my y coordinate is negative 1, so we'll write that as y plus 1, equals m, that's negative 1/3, times x minus my x coordinate of 1. And then again, you would take this and solve it for y, right? Take that, solve it for y. But essentially, these are the equations of my tangent lines. So please be very careful when working with implicit differentiation. Look out for those powers of x times those powers of y, because that's when you're going to need to use the product rule, and I think that's a really, really easy mistake to make. So just keep an eye out for that. If you have any questions, please feel free to email me.